This is lesson 3, inverse properties. What this is actually doing is explaining what you're doing, the calculations that are going on when we are solving equations. The two properties in particular we're looking at is 1, the addition, and 2, the multiplication. So the best way to think about this with the addition property is you think about what your goal is going to be. The goal of the addition property is always get it to equal 0. What this basically looks like is here you have a positive 5. What's the opposite of a positive 5? Negative. Negative 5, that equals 0. Here you have a negative 8. What is the opposite of a negative? That's a positive. You're going to equal negative 8 plus 8 equals 0. So the goal here is always to get it to equal 0. So basically the inverse property is telling you whenever you add the opposites to any number, it is always going to equal 0. When we put this into an equation, so now we have x plus 5 equals 10. What we're trying to do is cancel this so we can actually isolate the variable. How do we cancel a positive 5? Well, back to the addition rule. You do the opposite of it. So what's the opposite of a positive 5? A negative 5. And that's exactly what we're doing here. Notice that I'm working it actually vertically. You want to make sure you do that. Here you have positive 5 minus 5. Those two end up canceling each other and they equal 0. So what the inverse allows you to do is whatever you did to one side, you have to do to the other side of the equation. This is where we did a minus 5 here. We're going to do a minus 5 here. 10 minus 5, you're left on this side with just 5. Here the variable is by itself, x equals 5, and that is the answer on that one. Same thing if you had a negative. Say now you have x minus 2 equals 5. So we're still going to try and isolate the x. How do you isolate the x? You have to do the opposite of this negative 2 here. The opposite of a negative 2 is positive 2. That cancels that out. Whatever you do to this side of the equation, you have to do to the other side of the equation. That's where you get this positive 2. Notice you still have the two positive 2's. Here you're left with 5 plus 2 equals 7, and x equals 7. So that whole thing works out as far as that's concerned. Second property is the multiplication one. This one's a little bit different. So the multiplication goal is you want to get whatever you end up multiplying to equal 1. That's your goal. Get everything to equal 1. The multiplication inverse property basically just states that when you multiply any number by its reciprocal, it will always equal 1. What that basically means, let's say we have the number 5. The reciprocal means that we're going to flip it, so that we all know that this is also 5 over 1. When we multiply it by the flip, which is 1 over 5, it cancels itself out. So here, if you did top to top, bottom to bottom, you're going to have 5 over 5, which just equals 1. So there was our goal in that instance. Say we do it still with fractions. Here we have 2/3. If we multiply by its reciprocal, which here is 3 over 2, top to top, bottom to bottom, you have 2 times 3, which is 6 over 6, which is going to also equal 1. So your goal here is always to equal 1. So another way of saying that you're going to multiply by its reciprocal, the easier way is just thinking that you're just going to divide something. So when we see this on an equation, it would look like something like this. 2x equals 4. Okay, so what are we trying to do here now that we know that's 2? That actually means 2 times x. What you have to do, you're multiplying by the reciprocal, or in this instance, you're dividing, because you have to try and get a 1 here. So here's your divide. That's just the division symbol. You're dividing by 2. Whatever you do to one side, you always do to the other side of the equation. So here you have 2 divided by 2, which just equals 1. So I'm going to just keep x, just to show you that, to emphasize that it's 1x equals 2. There's your answer right there. Say we did another one. Say we were going to do something that was divided. See, now we have x divided by 3 equals, let's say, equals 7. So we know that this is a division one, so we're looking at what's the opposite of the division, or if we flipped this, it would mean it would be times 3. So that's what that means. I'll put a dot there just to emphasize that. So what we end up having is a 3 over a 3, which is 1. What you're left with here is x. Now we're multiplying by 3 here. X equals 7. So we multiplied by 3 here, and x equals 7 times 3, which is 21. So those are your two answers there for the multiplication one. Now, when we get to solving two-step equations, such as this one, what you always want to start with is what's the furthest or the one that's not connected with the variable. In this specific instance, the one that's not closest to the variable is your 1. So let's start with that. We see that this 1 is actually a negative 1. Back to the addition property. What's the addition property? We're trying to get a 0 here. We have a negative 1. The opposite of a negative 1 is positive 1 equals. We're going to have positive, we're going to do a plus 1 here as well. This cancels out. Always stick with what's left. So you still have 2x here. You cancel these ones out because that equals 0. Now you have 1 plus 1, which equals 2. Now we're doing the multiplication one. Since this is multiplication here, we're going to do the opposite of multiply, which is 2. We're dividing by 2. That's what that division symbol means. We're also dividing by 2 in this instance. Therefore, what's left? These cancel out, and they just equal 1. You're left with x equals 1. And that's how we solve that one. Now, it also works, you also have to deal with it when you see fractions. So I'm just going to change this equation to 2x. Instead of minus 1, now it's going to be plus 1 equals 1. So we end up still doing the same thing here. We're starting, if we have a plus 1, we're going to do the opposite of a plus, which is a negative. Minus 1, minus 1. So we're left with 2x equals 0, because we have 1 minus 1. When we divide by 2, reason you're dividing by 2 here, you're also still doing the multiplication. 2 times x, the opposite of that is 2 divided by x. 0 divided by 2 equals 0. We'll do one more just to emphasize this, and then we can get started on our lesson. We have negative 4x plus 3 equals 15. Okay, so let's start with what we do know. We have a plus 3, so what's the opposite? The inverse of that, we're going to do a negative 3. Also doing a negative 3 here. You always have to do them on both sides of the equation. That's what the inverse property allows you to do. It allows you to cancel it out on one side of the equation, and therefore it carries it to the other side of the equation. So now we have negative 4x. You're left with that here. Your equal sign, 15 minus 3 equals 12. Now, we have a negative 4x. Is this a subtraction or addition, or is this a multiplication problem? What you really have to look at here is that these two are connected. This actually means negative 4 times x. That's actually what's going on. So this is a multiplication problem. With multiplication problems, you always have to remember to carry the negative with yourself as well. So since multiplying, the opposite of that is dividing. We're dividing by a negative 4 because the goal is always to get yourself to 1. This cancels out to just equal 1. Now we're dividing this side by a negative 4 as well. Notice we're still consistent on both of these ends right here. Negative 4, negative 4. What you're left with on this side, x equals 12 divided by negative 4 turns it into a negative, equals negative 3. Now, if we ever do want to check yourself, go back to your original equation, which is negative 4. Substitute your x times negative 3. I got that from here. Plus 3 equals 15. So remember your orders of operation. Negative 4 times negative 3 would come first. Positive 12 plus 3 equals 15. And this is consistent and it checks out, so therefore the answer is correct. That's it for inverse property.